Hello. Hello viewers, we're now taking you through the story for A-Level Applied Mathematics, and this video I'm going to go through the marking guide for U.A.C.E of Uneb 2020 of Math Paper 2. So this video is suitable for students in both Senior 5 and Senior 6 offering Principal Mathematics as part of their combination. So Math Paper 2 has two sections. Section A has 8 questions and Section B has 8 questions. Now these 8 questions of Section A are compulsory, and these 8 questions Section B, a student must answer any 5. So because this is a revision, we shall do all the 8 in Section A and all the 8 in Section B. So question 1 says, the position vector of a particle at any time t seconds is given by this, meters. Calculate the speed of the particle when t is equal to 3. So here they have told us speed. Now this one is variable because it changes with time. Therefore you have to use calculus. So I'll come here and say that R. Now the reason why we use column vector is to bypass this I tilde, because if you just write I, most students write I without writing this tilde, and that will not be okay. So in order to bypass this I and J, we use a column vector. So I'll come and say that velocity, I'll get it by differentiating this displacement or position vector. So when I differentiate this, I'll come up with this. Differentiate this, I'll come up with this. But they want the speed at time t. So when t is equal to 3, I'll first get the velocity. So substitute for t here and for t there to come up with this. So I'm putting their units because in the question they gave us units. If the units were not given, you wouldn't have put them. So the question said speed. Speed is magnitude of velocity. So I'll come and say that the speed which is required is the magnitude of this, and divided by square root of this to give you 26 meters per second. And that is what they wanted. So the question analysis, the question required candidates to find the speed of a particle given its displacement in vector form. So the weakness is that candidates fail to use the necessary vector symbols. So that is why I told you it is advisable to use a column vector, because if you want to use IJK, you must put the tildes. Then also another weakness that candidates express the speed as velocity instead of finding the magnitude. So you should remember that speed is magnitude of velocity. Therefore at the end you have to get the magnitude. Then also another weakness is that candidates used inappropriate units for speed. So speed is meters per second because the displacement was meters and time was seconds. So you should write meters per second. Some could write kilometers per hour, which is not okay. Then advises that to teachers that teachers should teach students to differentiate between speed and velocity. So those two are different. One is the magnitude of the other. So if they ask for velocity, you leave the answer in vector form. But if they ask for speed, you must get the magnitude. Then teachers should encourage students to use the column vector approach in vector mechanics. So it's advisable to use column vector because here you'll have bypassed the I, J, and K. Because if you want to use I, J, and K and you don't put a tilde, then you're going to miss the marks. Then teachers should emphasize the use of appropriate units. So you must know the units for speed, velocity, acceleration, and all that. Then question 2 says the table below shows the values of x and the corresponding values of a function fx. So that the values use linear interpolation to find part A, fx when x is equal to 0.4, and part B, x when fx is 3.82. So we shall start with part A. So the first thing to do is extract out the values which you are going to use. So this 0.4 is between 0.3 and 0.6. Therefore, to get the, and y is what they want, therefore I'll say y minus 3 divided by 3.22 minus 3 will be equal to, so the order matters. What you do for y is the same thing you do for x. So it will be 0.4 minus 0.3 divided by 0.6 minus 0.3. So the order matters. After that, y is the only unknown, so look for a way of making it the subject, and y will be equal to that. Then for part B, they want x when fx is 3.82. So we shall come and extract out the values which we shall use in our calculations. So this shows that we shall use linear interpolation, therefore we shall come and say this minus this divided by this minus this will be equal to this minus this divided by this minus that. And here x is the only unknown, therefore we shall come and say make it the subject and use the calculator to get the answer they wanted. So the question required candidates to find the intermediate values using linear interpolation. But some candidates lacked uniformity in equating the gradients. So you must follow this the same way you do for x, the same order you do for y. If you interchange, then the answers will be different. Then also candidates fail to locate where the required values lie. So the required value must locate the correct position. It must be between two near values. The one which is here and here should be the nearest on either side. Then the advice to teachers is that teachers should emphasize the equating of corresponding gradients, and teachers should also guide students to locate intermediate values, and also to distinguish between linear interpolation and linear extrapolation. So in this case, everything was linear interpolation. Question 3 says the table below shows the prices of beans, maize, rice, and meat with the corresponding weights, and this is the table. Calculate Roman 1 the value of x given that the price indices of maize in 2.7 and 2.8 using 2.6 as the base year are this and this respectively. Then part B, the weighted price index for 2008 using 2007 as the base year. So this word 2007 equal to 100% is there to mean that this year 2007 is the base for these price indices. So first of all, we are given the price index of 2.7 using 2.6 as the base year, and it was 112. That means that price of 2.7 will be 1.12 times the price of 2.6. So what I've done, I've brought this one this side and this one this side. I've made this here the subject. Similarly, for 2.8 using 2.6 as the base, make 2.8 the price of 2.8 the subject, and you'll come up with this. Therefore, the value of x will be the price of 2.8 divided by the price of 2.7 times 100. So you know the price of 2.8 is this, come and substitute. Price of 2.7 is this, come and substitute. Multiply by 100 to come up with this as the answer they wanted. Then for part B, they want the weighted price index for 2.8 using 2.7 as the base year. So when they say weighted price index, they mean weighted average price index. So you come and code the formula, then substitute. So in this case, we put this 100 would have been outside, but because the values in the question are already multiplied by 100, that is why we bring it inside here. So the whole of this is equal to what is in the table. That is why you are writing the whole of this will be equal to this, this, and that. It's already multiplied by 100. Then times the weight for each, weight for this, weight for this, weight for this, weight for that. Then over the total of the weights. Then use the calculator, and that will be the answer they wanted. So part A required candidates to obtain the value of the unknown price index using the given price indices with a particular base year. And part B required candidates to determine the weighted price index. The question was not popular. Not popular means it appears less frequently in the previous years. And the weakness is that some candidates could not multiply the price indices by 100. So this is what I told you. Let's first go back. Here, most candidates, they thought that price index is this over this. They ignored this 100 and also ignored this 100. That gives the wrong value. So when the price index is in hundreds, you must know that it was multiplied by 100. If it wasn't, it should have been 1.12. But this was 112, meaning it was already multiplied by 100. That is why even here, the price index is already multiplied by 100. That is why I'm putting 100 inside. Then also other candidates failed to correctly use the base year in the calculation. So you must know the base year before you calculate the price index. Then the advice to teachers is that teachers should emphasize that multiplication of price indices should be by 100. Teachers should also illustrate to the students that the base year values are always in the denominator while the current year values are in the numerator. So you should be able to know that. Base year, denominator, current year, numerator. Then question 4, a particle moves with simple harmonic motion about a mean position O with periodic time of this. When the particle is 0.8 meters from one extreme end, its speed is this. Determine the amplitude of the motion. So first of all, the period is 2 pi over omega. That means that when I equate to this period here, I'll be able to get the value of omega as 3 rads per second. Then when I use this formula, that velocity squared is equal to omega squared in brackets r squared minus x. So this is angular velocity which I've got. This is the amplitude which they want, and this is the displacement from the mean position. You must remember that. Displacement from the mean position. That means that in this question, it was a little tricky because they gave you the distance from the extreme end, yet the x, they want displacement from the mean position. So how do you get that? If this is the end and this is the mean point, we know that the whole of this is amplitude. Therefore, if I'm given this as 0.8 from here, it means that the remaining part will be r minus 0.8. That's why I'm putting here r minus 0.8. Now I have only one unknown, so my aim is to look for a way of making it the subject. When I open brackets here, I'll come up with this. And then also this side, this one was taken this side. So 3.6 squared divided by 3 squared gives you 1.44. Then this r is here, minus, this minus is here, Then the whole of this was expanded to give you this. Then when I open brackets, you realize that this and this can cancel. Then this with this gives you a plus. This with this gives you a minus. Then you collect like terms and make R the subject. And that's what they wanted. So the question required candidates to determine the amplitude of a particle moving with simple harmonic motion. However, the candidates failed to determine the displacement. That's just like I told you, x is displacement from the origin, but the question gave you distance from the extreme end. Therefore, you had to first get the displacement from the origin. Also, candidates used wrong expression for velocity in simple harmonic motion, which led to incorrect computation. So the expression for velocity in simple harmonic motion is a little different from that of linear motion. Then advise to teachers that they should distinguish between displacement measured from the center and the displacement measured from the ends. So in the calculation, we use displacement measured from the center. So if I give you displacement measured from the ends, you must get amplitude minus that displacement to get this displacement, which we will use in the calculation. Then also, teachers should encourage students to refer to formulas in simple harmonic motion given in the mathematical table. So those formulas are there for you to use. So you must always go with the mathematical logbook in an examination. Then question 5 says the numbers x equal to this, y equal to this, and z equal to this have been rounded off to the given decimal places. Find the maximum possible value of this quotient correct to 3 decimal places. So first of all, the error in x is this. So if it is 1 decimal place, it will have 0, 1, 0. If there are 2 decimal places, they will have 2 zeros here followed by 5. If there are 3 decimal places, they will have 3 zeros followed by 5. Therefore, the maximum of this quotient means the numerator is maximum and the denominator is minimum. For a maximum numerator, we shall put a plus here. For a minimum denominator, z will be minimum and x will be maximum because it is a subtraction. Then we shall use the calculator and get what they want to 3 decimal places. So the question required candidates to find the maximum possible value of the expression given. The weakness is that candidates failed to obtain the correct errors of the given values. So must know that the number of zeros correspond to the number of decimal places in the given values. Then also, candidates lacked the knowledge of maximizing the given expression. So knowing here, if you go back here, so for this quotient to be maximum, you must remember that the numerator must be maximum and denominator is minimum. Also, you must know that for a minimum in subtraction, the first value must be minimum and the next value must be maximum. So that will also disturb candidates. Then also others could not round off to the required number of decimal places. So if the equation specifies the accuracy, you must also round off to the required accuracy. Then also candidates calculated the minimum value which was not required. So some candidates are used to calculating both maximum and minimum, then state the error. But in this case, they only asked for maximum, meaning the minimum value was not required. So advice to teachers that teachers should emphasize the identification of errors of given values during maximization, and also guide students to always use the required degree of accuracy. So when the accuracy is given, always use that. Then question 6 says two events are such that PA is that, this is that, and this is that. Find probability of A union B and probability of A intersection B complement. So probability of A union B, probability of A intersection B is what we shall get first. It will be probability of B times probability of A given B. Like I told you, this one, what is here is what should appear here. That's why I'm using probability of B and not probability of A. So when I substitute, probability of B is 0.2, probability of A given B is 0.1. So probability of A intersection B will be 0.02. Now that I've got intersection, I can now get the probability of A in A union B. So I come and substitute for probability of A, probability of B, and probability of A intersection B to come up with that. That was part A. Then part B, they want probability of A intersection B complement. So there I use contiguous table. A intersection B complement is equal to probability of A minus probability of A intersection B. So probability of A is that, probability of A intersection B is this, to give you 0.68. So the question required candidates to find probabilities of union and intersection of described events. The weakness is that candidates fail to state the expression for conditional probability. So this conditional probability what you should know is that what is after the slash is what should appear here. So candidates failed to write that. They wrote probability of A times this conditional probability, which is not okay. Then also candidates mistook the events as independent events, hence used wrong expressions. So when they don't tell you that the events are independent, don't use independent events. So what most candidates did when it came to this intersection, when it came to getting probability of A intersection B, they said is equal to probability of A times probability of B, which is not okay. So when they don't specify that the events are independent, don't use that condition. So the advice is that teachers should distinguish between the concepts of conditional probabilities and probabilities of independent events. So here in this case it was conditional probabilities, not independent events. Then also teachers should encourage students to refer to formulas of probability given in the mathematical table. So I've always encouraged you to go with your mathematical logbook in an examination. It is for you, so don't leave it behind when it's time for an examination. Then question 7 says, a particle of weight 20 newtons is placed on a rough plane inclined at an angle of 40 degrees to the horizontal. The coefficient of friction between the plane and the particle is a quarter. When a horizontal force P is applied on the particle, it rests in equilibrium. Calculate the value of P. So here the first thing to do is to illustrate, to draw a force diagram. So you have a particle, the plane is inclined at 40 degrees to the horizontal, and this is the particle. So we shall show the forces acting. One is the weight, which is 20 newtons. Another one will be the component of that weight along the part of the plane, which is 20 sine 40 degrees. And the component of that weight perpendicular to the plane, which is 20 cos 40 degrees. Then we have the normal reaction, R. And then they said this, they talked about coefficient of friction, meaning there will be friction. Now in equilibrium, this particle will be at the point of sliding downwards. Therefore, friction must oppose motion. But before we oppose motion, let's first put the horizontal force. So the horizontal force is P, so it is that. Then you also have to resolve it. It has two components. There is a component parallel to the plane. It will be P cos 40 degrees. And a component perpendicular to the plane. It will be P sin 40 degrees. Then the acceleration will be downwards, but it will be 0 because it is still in equilibrium. Therefore, friction will oppose motion, therefore it will be upwards, which is mu r. So that is the first diagram. Now we shall go and get the value of P. To get the value of P, we must resolve both perpendicular to the plane and parallel to the plane. If we start by resolving perpendicular to the plane, it will be this one will be equal to these two. So you come and say that R is equal to P sin 40 degrees plus 20 cos 40 degrees. Then after that, we shall also resolve parallel to the plane. So parallel to the plane means this is equal to this. So you come and write that this will be equal to this. Therefore, when I substitute for R, where there is R, I'll put there this expression, and where there is mu, I'll put there this a quarter. Now when you look at the question, when I look at this line, I have only one unknown, which is P. So from here, my work is to look for a way of making P the subject. So when I open brackets, this bracket, I'll come up with this line. And next will be to collect like terms. And next will be to make P the subject. And that will be the answer they wanted. So the question required candidates to determine the value of the horizontal force acting on the particle resting in equilibrium on an inclined plane. The weakness is that candidates fail to indicate all the necessary forces on the diagram. So all the forces must be shown, the forces of the horizontal force, weight, and the friction. Then also weakness was that proper directions of forces were not shown. So especially the direction of friction, because in this case, they did not specify the particles at the point of moving downwards or upwards. So their candidates failed to figure out where the direction of friction would be. But if they don't specify, then it must be at the point of moving downwards. Then the first diagram was drawn using freehand instead of a straight edge. So this is what I always encourage you, that in an examination of mechanics, you must have a long ruler, because all forces must be drawn using a ruler. If you draw using freehand, then you're going to miss marks right from the start. Then also candidates failed to resolve forces along the plane and perpendicular to the inclined plane. So resolving was also a challenge to many candidates. So in mechanics, resolving and taking moments are the two major concepts which must be at your fingertips. So resolving, you must look for ways of mastering it. Then advice to teachers that teachers should illustrate the use of rulers while drawing any mechanics diagram. So always when you are drawing any diagram of mechanics, ensure that you have a ruler nearby. Then so teachers should differentiate between mass and weight of quantities. So most students, what was given was weight because it had a unit of Newton. If this was 20 kilograms, it would be mass. But what most students did, they got this 20 and they added on a G, which is not okay. Then teachers should emphasize correct resolution of forces along the perpendicular to the plane to the inclined plane. So resolving, you must understand, you must master it. Then question 8 says, a mobile phone dealer imports Nokia and Motorola phones. In a given consignment, 55% were Nokia and 45% were Motorola phones. The probability that a Nokia phone is defective is 4%. The probability that a Motorola phone is defective is 6%. A phone is picked at random from the consignment. Determine the probability that it is defective, and part B, it is a Motorola given that it is defective. So just start with part A, defective. So here the easiest way is to use a tree diagram. So here N means Nokia phone and M means Motorola. D means defective and D complement means it is not defective. So we are given that the probability of the Nokia was 55%, so 55% is 0.55, and this was 45%, which is 0.45. Then here defective for Nokia, it was 4%, which is 0.04, and meaning the opposite, the complement will be 1 minus 0.04, which will be 0.96. Then defective for Motorola was 6%, which is 0.06, and the complement will be 1 minus 0.06 to give you 0.94. Therefore, if I want the probability for defective, it will be there is defective here and defective here. So I'll say this times this, which gives me this, plus this times this, which gives me this, and the end I'll come up with 0.049. Then part B, Motorola given defective, it is a conditional probability, M given D, meaning that numerator will be intersection, denominator will be probability of D, which you have got here. So intersection will be this times this, which it was already got here. Remember, it was already, this one corresponds to this, and to simplify to this. That is why I'm writing here 0.027. Then probability of defective was already got here, so I'll come and put it there. So when I divide, I'll come up with this. So you can either leave your answer in this fraction form or you use decimals. And that's what they wanted. So the question required candidates to determine the probabilities having defective phones in a given consignment. The weakness that candidates fail to express percentages as fractional or decimal probabilities. So when given percentage, you must know that in fraction it is divided by 100. For example, 55% would be 55 over 100. So I can either express it like this, or I use decimals, which is 0.55, and that's what we used in the question. So also candidates had difficulty in matching the corresponding correct entries. So substituting the probabilities along the tree diagram was also a challenge. Then also candidates missed two conditional probabilities for probabilities of independent events. So we must know the difference between conditional probability and independent events. So when it is conditional, that is when you use a tree diagram. And that's why you saw me using a tree diagram. The advice to teachers is that teachers should expose students to various probability situations. All those ones: independent, mutually exclusive, exhaustive, or unconditional. The students should be able to do a lot of worked examples for them to master. Then also teachers should distinguish between the concepts of conditional probabilities and probabilities of independent events. So that was section A. Now we shall go to section B. Question 9 says, the table below shows the marks obtained by 100 students in a mathematics test. These are the marks and these are the number of students. Part A, calculate the mean mark, and part B, draw a cumulative frequency curve, which is the ogive, and use it to find the median mark, and part B, the range of the middle 40% of the marks. So yeah, the first thing to do is to tabulate. So for the column of marks, I'll put there these very marks. But now these ones, if you see these inequalities, it means that the classes are the same as the class boundaries. Then also this number of students will be now the frequency. So I'll come here and say that for marks, I'll put those ones. So in this case, classes are the same as class boundaries, therefore I'll use only one column for both classes and class boundaries. That is why you are not seeing any inequalities anymore, because the classes are the same as the class boundaries. Then next will be frequency, so the values for number of students will be the frequency. And in the end I have to get the total, which is 100. Then next will be getting the values of x. X is the midpoint, so this plus this divided by 2, you come up with this. This plus this divided by 2, 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 and this plus this divided by 2. Okay, so those are the values of x. Next is to get the values of fx. Fx means I will keep on multiplying. This times this gives you this times this, 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 this times this. Then I have to add all these ones. So when I add, I'll come up with that. So this fx and f will help us to get the mean, but they also told us to draw a cumulative frequency curve, meaning we need a column of CF, which is cumulative frequency. Here we shall first write this very one here, then this plus this to give you, then this plus this to give you, then this plus this to give you, this plus this to give you, this plus this to give you, and this plus this to give you. So what you should realize is that this total frequency is the same value here. If they are not, then there's a mistake somewhere. So now we shall go to part A. Part A, they want you to get the mean. So mean will be summation of fx divided by summation of f, to give you this as the answer they wanted. Then for part B, they wanted you to draw a cumulative frequency curve. Therefore you'll need a graph paper. Then you draw the axes, horizontal and vertical. Then you should get a scale. For the horizontal axis, and also a scale for the vertical axis. Then from there, you are going to start plotting. Remember, we plot upper class boundaries. We plot these ones with these ones. So the first one will be 40 corresponding with 5 to give you this. Then 50 corresponding with 20 to give you this. 55 corresponding with 30 to give you this. 60 corresponding with 45 to give you this. 70 corresponding with 70 to give you this. 90 corresponding with 95 to give you this. And lastly 100 corresponding with 100 to give you this. So next is to draw a reasonably smooth curve through all these points, and must not be left hanging, meaning it should go up to the start, the origin. So let's draw that smooth curve. So here it should not exceed the last value. So that was part A. Part B, Roman 1. Part B, now let's go to part B, Roman 1. They want the median mark. So for you to get the median, you need the median position. So median position will be 50 because this is 100. So I'll come here and first get the median position. So median position is a half n, which is half times 100 to give you 50. Therefore, I'll come here and look for 50, then take a horizontal line to meet this, and take a vertical line to meet the horizontal axis, and read off that value. And that will be the value of the median they wanted. So I'll come here and state that the median is that. Then Roman 2, they wanted range of the middle 40%. So here we need to first make some illustration for you to know what the middle 40% means. So remember, percentages range from 0 up to 100, so that is P0 to P100. Then this will be the midpoint. So the middle 40% means this 40 is divided into 2 halves. When you divide this 40 into 2, this half will be 20% and this half will also be 20%. As you can see it there. Then what does that mean? It means that, first of all, from here up to here, it is 50. Therefore, this remaining part will be 50 minus 20 to give you 30. That means that this is P30. Then also this remaining part will be 50 minus 20 to give you 30. So this is 100, so 100 minus 30 gives you 70. Here I got 30 because 0 plus 30 is 30. That means that the range of the middle 40% ranges from P30 up to P70. So range of the middle 40% range is P70 minus P30. Therefore, I forget the position of P30, which is 30 over 100 times 100 to give you 30th position. Therefore, I'll go here and locate the 30th position and take it to meet the curve, then take it downwards to meet the horizontal axis and read off that value. So that will be our P30 position. What about the P70 position? P70 still 70 over 100 times 100 to give you 70th. So I'll still come here and locate the 70, take it downwards to meet this, which is 100 of this value. So P70 is 70. Now I have P70 and I have P30. Therefore, to get the middle 40% range, I'll have to subtract. And that will be the answer they wanted. So part A required candidates to find the min mark of group data with unequal class width. And part B required candidates to draw an ogive and estimate the median mark and the range of the middle 40% of the marks. So the weakness is that some candidates could not determine the mid-marks X of the classes. So mid-mark you have to add and divide by 2. Then also candidates failed to accurately compute the product Fx and the correct sum. So using a calculator, you must not use a calculator when you're computing. Then also some used non-uniform scales of the axis. So the scale on the graph must be uniform. In the question, the classes may have unequal class widths, but on the graph, the scale has to be uniform. Then others drew the ogive with a ruler instead of freehand. So ogive must be drawn using a free hand, and it must be reasonably smooth. The estimation of the range of the middle 40% from the ogive was a challenge to many candidates. Then advice to teachers. Teachers should expose students to ungroup data that has classes with inequalities. So most students, the inequalities disturbed them. Then also teachers should illustrate to students how to label axes using uniform scales and draw ogives with free hand. Then teachers should guide students how to use an ogive to estimate a variety of parameters. So all gives are very vital in math statistics, therefore you must master them. Then question 10 says, two bodies A and B of masses 3 kilograms and 2 kilograms respectively are 7 meters apart on a smooth horizontal surface. A is moving directly towards B with a speed of 2 meters per second and an acceleration of 0.3 meters per second squared. B is moving in the same direction with A. B is moving in the same direction as A with a speed of this and a retardation of this. If the bodies collide and coalesce, calculate part A, the time taken before collision occurs, and part B, the common velocity immediately after collision. So let B move a distance x before collision. Then it means that for body A, using this second equation of motion, the distance moved will be x plus 7, and the initial velocity will be 2 time, we don't know it, acceleration is 0.3. When I simplify, I'll come up with equation 1. Then for body B, using the second equation still, distance moved is x, initial velocity is 5, acceleration is 0.2. But here, I'm putting a minus because there is a change in direction. And it was retardation. If I look here, it was a retardation, meaning it has been negative. So when I simplify, I'll come up with that. So for body B, I'll still use the second equation of motion and substitute for displacement is x, initial velocity is 5, acceleration, it was retardation, that is why there is a minus here. So I have now two equations and two unknowns. So I can substitute equation 2 into equation 1 to come up with that. So now here I have only one unknown, so I have to look for making it the subject. When I collect like terms, I'll get a quadratic and solve it using either factorization or bulldozer. However, bulldozer is recommended. So I'll come up with two values of t, but one is negative, so t cannot be negative. So yeah, I forgot negative. T cannot be negative 2, therefore t is 14. And for part B, the one, the common velocity immediately after collision. So for body A, V is equal to U plus AT. So U is this, A is that, and T is that. Therefore, the velocity will be that. For body B, V is equal to U plus AT. U is that, A is that, retardation, that's why there's minus, and T is that, V is that. Therefore, by conservation of momentum, MAVA plus MBVB is equal to MA plus MBV. So this was before collision, this was after collision. So I'll come and substitute and simplify to get V. And that's what they wanted. So question analysis, the question required candidates to capture the time and common velocity when two bodies collide and coalesce given the velocities. It was not a popular question. So the weakness that candidates failed to distinguish between acceleration and deceleration. So deceleration, they should be a negative. Then also they failed to determine the displacement between the two bodies. Then also they failed to solve the quadratic equation and to identify the positive roots of time. So we must know how to solve quadratic equations and eliminate the negative time and take the positive time. Then also they failed to calculate the initial velocities in order to obtain the common velocity. So they had to calculate the initial velocity because they had moved for some time before they collided. Then advise that teachers should differentiate between acceleration and deceleration and the respective signs during computations. So acceleration has a positive value, deceleration has a negative value. Teachers should emphasize to students that time is a scalar quantity and can never have a negative sign. So time, that's why we eliminated t equal to -2. Then teachers should illustrate application of linear motion concepts to linear momentum. So now we shall go to question 11, which says, Part A, use trapezium rule with 6 ordinates to estimate this integral correct to 3 significant figures. Then 2, they want you to evaluate this one correct to 3 significant figures. So let's start with part A. So this y is the given integral they want you to integrate, and h will be the strip width, which is got by upper class limit minus lower class limit over number of ordinates minus 1 to give you 0.08. So this number of ordinates minus 1 helps you to get the sub-intervals. If the question had only sub-intervals, we wouldn't have subtracted 1. But if they give you ordinates, you must subtract 1. Then next is to tabulate. First, you need the number of ordinates. So it is 0, 1, 2, up to 5. Then next, you need x values. X values, you start with the smallest here, lower limit, then keep on adding this. So add this to give you this, add again 0.08 plus 0.08 plus 0.08. And when you reach the upper limit, you stop. The next will be the extreme ordinates, the first and last. So the first one will be this. When x is this, substitute to get y0, and when x is this, substitute to get y5. Then you add these two to come up with that. So what you should note is that we are using more than 3 significant figures. Here the question wants 3, but we have added on 2 more to get 5 significant figures. Then the intermediate ones, put this here to get that when x is this, when x is this, and when x is this. Then add all these ones to come up with this. Then we can code the formula of trapezium rule. It is available in your logbooks, and we substitute for h, substitute for this, and substitute for this. Then use a calculator to get this value, but they want 3 significant figures, so we round off to 3 significant figures. Then evaluating means you use the knowledge of calculus to integrate. So when I integrate this one using calculus, it will be a half ln 2x plus 1. Then substitute the limits to give you that. Then use the calculator because they want the answer to 3 significant figures. So it gives you that. That was part B. What about part C? Part C, Roman 1 said, determine the percentage error in the estimation in A above correct to 2 decimal places, and suggest how the percentage error may be reduced. So the good thing, we have the approximate value. The one got by trapezium rule is approximate, and the one got by calculus is the exact. So you come as the percentage error is equal to magnitude of actual value minus approximate value over actual value multiplied by 100. So the formula for percentage error. Then you shall substitute actual value, approximate, actual times 100. Now here, most students, when they see that this one's bigger than this, they interchange and say 0.256 minus 0.255. That will not be okay. The order matters. Actual minus approximate. And the magnitude signs have to be seen. So I'll come up with this as the answer to decimal places. Negative is not there because of this magnitude sign. Magnitude means what is negative becomes positive. Then Roman 2, how the error may be reduced. It is by increasing the number of ordinates within the given interval. So the question required candidates to estimate the integral value of the given functions using trapezium rule, calculate the exact value using integral of the integral using calculus, and then determine the percentage error and how the error may be reduced. So candidates failed to obtain the width from the given number of ordinates. So they forgot to subtract 1 from the number of ordinates. Then also they failed to evaluate accurately the given definite integral. Using calculus was also a challenge. They failed to use the necessary number of decimal places during computation, which led to premature approximation and truncation. So when the question wants, in this case it was three significant figures, so we have to use 5, you have to add on 2 more to get 5 significant figures. Then also they failed to correct the required number of significant figures and decimal places. Here they wanted 3, so at the very end you must round off to 3 significant figures, and for percentage error they wanted 2 decimal places, so at the very end you round off to 2 decimal places. Then advice to teachers: teachers should emphasize the concept of absolute value in relation to trapezium rule and exact value by integration. So in this topic, the approximate value is the one got by trapezium rule, so this has to be absolute approximate, and the exact value is the one got by integration. Then teachers should clarify significant figures and decimal places in numerical methods. So significant figures and decimal places, the required accuracy is for the final answer, but during computation they should be more than the required accuracy. That's why you saw me using 5 significant figures in the table, not 3. Then teachers should guide students to refer to formulas of integration given in the mathematical table. So the mathematical logbook, you must never avoid it. Question 12 says a continuous random variable x has a cumulative distribution function given by this. Then determine the value of k and hence sketch the graph of this. Find the probability density function of x. So here we should know that the total must be equal to 1. So this one, f3, must be equal to 1, total probability. Therefore, we shall come here and say that for part A, f3 is equal to 1. So substitute for f a where there is x, put there 3, and then simplify and make k the subject. After that, we shall bring the k, we shall come here, and where there is k, we shall replace it with the value of k we have got to come up with capital F of x as that. Then next, they also wanted you to sketch the graph. So to sketch the good thing, we already know that f0 is 0, f3 is 1, but f2 we don't know it yet. So we shall first get f2, which will be 2 over 3. Then we can now sketch our graph. So 0, 0, then 2 is 2 over 3. Therefore, the curve will be in that form. So why is it in this form and not in this form? To know the shape of the curve, first of all, it is not a straight line. That's what you should realize. It is not a straight line because the x has a power, meaning it is a curve. So when after that you look at the sign on x squared, here it is positive, meaning it will be in this form. This is for positive. Then when it is negative, it will be in this form. For example, if you look at this, the sign on x squared is negative, meaning the shape will be in this form. I think let's draw it for you to identify it. So I think you realize the shape is in this form for negative x squared and this form for positive x squared. It is not a straight line. Then what you should note is that each curve has been labeled, but this is not the end. We have drawn this. There is also this one. It shows that for x greater than 3, fx is 1. We don't know where it stops, so we shall come and put an arrow to show that it is still continuing. So what you should realize is that each curve has been labeled. That is 1. 2, the axes have been labeled. And 3, the necessary points have been shown. So that was part A. What about part B? Part B, they wanted the PDF of X. Now from capital F to small f, you are supposed to differentiate. So you shall come and differentiate term by term. Then you should remember that we put 0 elsewhere at the very end. So when I differentiate this, and here 2 is common, so if I cross it out to come up with this as my small f of x, which they wanted. So part A required candidates to determine the value of the constant in the given cumulative distribution function, and hence sketch the graph of the function. Part B required candidates to generate the PDF from capital F. So the weakness that candidates fail to apply the formula fx equal to 1, the total is equal to 1, total probability must always be equal to 1, in the last interval in order to obtain the value of the constant. And also they fail to rewrite to the function of fx. So after getting the constant, you must rewrite the function of fx, capital F of x, with the constant substituted. Others could not label the axes, curves, and lines on the sketch. So the axes must be labeled and the curves must be labeled. Then some candidates used a ruler to draw the curve instead of freehand. So this was the curve, it was not a straight line. When you see a power on x, it is no longer a straight line, so you have to use freehand. Others fail to differentiate fx in order to obtain the distribution small f. So differentiation, some candidates chose to integrate. Integration is when you are converting from small f to capital F. But when it is capital F to small f, it must be differentiation. Advice that teachers should clarify the difference between the two functions, capital F of x and small f of x. Then they should also guide candidates to rewrite functions after obtaining the constant. And also emphasize students to label axes, lines, and curves. So labeling is a must. Then to illustrate use of freehand while drawing curves and ruler for lines. Then emphasize correct differentiation of fx to obtain small f of x. So what does that mean? It means that some candidates, they differentiate but they don't add that part of 0 elsewhere. It must be seen. Then question 13 says, the diagram below shows strings A, B, BC, and CD. A and D are fixed to small rings, each of mass this, which can slide on a rough horizontal rail AD. Masses M1 and M2 are attached at B and C, respectively. The system rests in equilibrium, with BC at a distance of 12 centimeters below AD. Part A, show that 9M1 is equal to 5M2, and Part B, if the coefficient of friction between each ring and the rail is a quarter, and the ring at A is on the point of slipping, determine the value of M1. So here we shall first redraw the diagram and then show the forces acting. So we shall start with the weights. So at B, the weight will be M1G. At C, the weight will be M2G. Then at A, the weight will be 2G. And at D, the weight will be 2G. After the weights, we shall go to the tensions. Here it will be T1, and also here it must be shown in opposite direction. Here it will be T2, and here it will be in opposite direction, T2. Here it will be T3, and also here in opposite direction, T3. Then the friction at A. First of all, here at A there will be normal reaction R1 and friction, which is mu R1. Then at D, there will be normal reaction R2 and friction F2. Now we are not using mu R2 because the equation only specifies that this one is at the point of slipping. They didn't talk about D, therefore we can't write mu R2. Then using the given lengths, we can get sine theta. Sine theta is opposite, so opposite, which was 12, divided by hypotenuse, which is 15. And this adjacent will be got by Pythagoras theory to come up with cos theta 1 as that and tan theta 1 as that. For theta 2 still, this was 12, but this was 13. So sine will be 12 over 13, cos will be 5 over 13, and tan will be 12 over 5. We shall see how to use these ones. Then part A, we shall first resolve vertically and horizontally at B. So if we come here at B, this T1 is going to the left, and when resolved it will be T1 cos theta 1, and this one is going to the right. So T1 cos theta 1 is equal to 3. Then vertically, M1G is equal to T1 sine theta 1. So you come and resolve that. So you have that vertically and that horizontally. So when I divide the two equations, I'll come up with that. Then this cancels, and this gives me tan to come up with that. But I know that tan theta 1 is equal to 12 over 9. So substitute, then make T3 the subject. Then what about at C? When I resolve at C, horizontally it will be T3 equal to T2 cos theta 2, and vertically it will be M2G equal to T2 sine theta 2. So I'll come back still, and so shall come and also resolve at C, horizontally and vertically. So vertically it is that, horizontally it is that. When I divide the two, I'll come up with this. Now this cancels to remain, and this gives you tan to give you that. But I already know that tan theta 2 is equal to 12 over 5. Therefore, T3 will be equal to that. Now, we have T3 here and also T3 here, meaning I can equate the two. So when I equate, I'll come up with this, and here this can cancel, this g can cancel, so I remain with 9m1 equal to 5m2, which is required. That was part A. What about part B? Part B, they said if the coefficient of friction between each ring and the rail is a quarter, and the ring at A is on the point of slipping, determine the value of M1. So here it means that we have to resolve. If I resolve vertically, it will be R1 equal to 2G plus this component of T, which is T1 sine theta 1. That is vertically. What about horizontally? Horizontally, there is this one, which will be equal to T1 cos theta 1. So when we shall go here and resolve. So resolving vertically, R1 is equal to 2G plus T1 sine theta 1. But T1 sine theta 1 is equal to M1G. We already saw that here. Let's go back and see. Here we saw that T1 sine theta 1 is M1G. Therefore, we shall come and say that R1 is that. What about resolving horizontally? T1 cos theta 1 is equal to mu R1. But T1 cos theta 1 is equal to T1, which is equal to that. And mu is equal to a quarter. Therefore, we shall come and substitute for this and for this mu and for this R1. Then I think here it is only M1 which is the only unknown, so I have to look for making it the subject. When I open brackets, I'll come up with this, collect like terms, and make M1 the subject. And that's what they wanted. So the question required candidates to apply the concept of jointed rods in equilibrium in order to obtain the unknown masses given the coefficient of friction. Weakness is that candidates failed to obtain relevant forces, angles, and ratios from the diagram. So drawing the correct force diagram was a challenge. Then also resolving vertically and horizontally was also a challenge, and taking moments about suitable points. So in this case, I only use this concept of resolving, but you can also use the concept of taking moments. Then also drawing the force diagram using a straight edge. So that means that force diagram must be drawn using a ruler. Advise that teachers should encourage students to draw force diagrams using a ruler. Then also differentiate between mass and weight. Mass and weight are different. Mass, to get weight, will get mass times acceleration due to gravity. Then teachers should illustrate all the relevant forces acting on a system in equilibrium. So all forces must be shown on the diagram. Then guide students to resolve horizontally, vertically, and take moments about suitable points. So in mechanics, resolving and taking moments is very vital. They are the key concepts. So you should look for ways of mastering them. Then question 14 says, part A, Roman 1, draw on the same axis the graphs of this and this for this range. And Roman 2, use your graphs to find an approximate root of the equation this. So here we shall first tabulate. So we shall need values of x, first function, second function. So for 0.5, this will becomes that, and this becomes that. Then when x is 0.7, we shall have this here, and this becomes that. 0.9 we have that and that. 1.1 that and that. 1.3 that and that. Then 1.5 that and that. So what you should realize on these values is that what is given in the question must not be altered. They want x from 0.5 to 1.5. What does that mean? It means that here your values must start from 0.5 and end at 1.5. If you start from 0.4, it will not be okay because it is outside the range. If you end at 1.6, it will also not be okay because it is outside the range. Then plottable values must be 5. 1, 2, 3, 4, 5, 6. So here we have 6, which is okay. So it should be 5 or more. If you get 4 plottable values, then it will not be okay. They should be 5, and 5 should be the minimum of the values to plot. Then you'll get your graph paper and you'll draw the axes, both horizontal and vertical. Then you get the scale for the horizontal axis. Also get the scale for the vertical axis. Then you start plotting. We shall start one function at a time. If I start with this one, 0.5 corresponds with 0.24, which is here, 0.7 with 0.45, 0.9 with 0.70, 1.1 with 0.98, 1.3 with 1.25, and 1.5 with 1.5. So we shall draw a smooth curve through the points. Let's do that. So what you should realize that this is not a ruler. You don't, even if the values form a straight line, you must not use a ruler. So you have to draw the curve and label it. The axis must also be labeled. The next function, 0.5 is negative 0.35, 0.7 with 0.01, 0.9 with 0.46, 1.1 with 1.0, 1.3 with 1.67, 1.5 with 2.48. Then you also join the points using freehand. So let's do that. Then you also label the curve. Then Roman 2, they wanted you to get the approximate root, so we have to get the point of intersection and read it off. That will be the root. So this root must be written on the graph paper. Then part B says using Newton-Raphson method iterative formula and your approximate root in Roman 2 above as the initial value. Calculate the root of the given equation correct to 3 significant figures. So like I've already said, when they say 3 significant figures, you add 2 more and use 5 significant figures. So we shall come and write our fx, then differentiate it. So this is the product rule, that's what you use to differentiate it. Then we code the formula and substitute for fx and f prime x. But this time there is xn, not just x. Then initial root is this. I think we realize there are 5 decimal places. Then you can substitute. Now because there is this sine trigonometric function, the calculator must be in radians. When you put the calculator in radians and you carefully punch in this, you will get an output of this. How do you know where to stop? Get this one 3 decimal places, it is 1.080, and this one 3 decimal places, it is 1.085. So they are not the same, meaning we have to proceed. So I'll go ahead to x2. and use the calculator very well, use in radians, then you come up with this value. Then you ask yourself, should I stop there or not? So to know where to stop, come and round this off to 3 decimal places. It is 1.085. Round off this to 3 decimal places, 1.085. So they are the same, meaning that would be the root they want. So we'll come and conclude that the root is 1.085 to 3 decimal places. So what you should note is that in the computation, I used more than 3 decimal places. At the final answer, I wrote the required accuracy. So the part A required candidates to draw graphs of 2 functions on the same axis and use the graphs to approximate the root of the given equation. Part B required candidates to use Newton-Raphson iterative formula and the approximate root to calculate the root of the equation. However, candidates failed to set the calculator in radian mode. So the calculator must be in radians for you to get this value of the function, and also in the substitution of Newton-Raphson method. Then 2, they failed to label axes using and also to use a uniform scale. So axes must be labeled both horizontal and vertical, and the scale has to be uniform. Then also they failed to locate the root from the graph. So on the very graph, the point of intersection is where you locate the root. So the root must be written on the graph paper. Then they also fail to differentiate the given function to be substituted in Newton-Raphson formula. So some candidates failed to realize that they had to use product rule to differentiate the part which is x sine x. So product rule, you must be conversant with it for you to do such questions. Then they failed to correct the root to the required number of decimal places. So at the end of it all, you must round off to the given accuracy. Then advise that teachers should demonstrate to candidates how to set calculators in radians. So candidates should know how to set calculators in radians. Then emphasize labeling. So the axes must be labeled, the curves drawn must be labeled, and the scale has to be uniform, and the root must be located on the graph paper. Then teachers should encourage students to use one or more than one decimal place of the required accuracy. So here, if the accuracy requires 3 decimal places, you should use 1 or more. You can use 4 decimal places or 5 decimal places. But if you use 3 decimal places, then the computation will not be okay. Then question 15 says, a certain football team has 3 matches to play. The probabilities of winning the first, second, and third matches are these, respectively. Part A, find the probability that the team wins Roman 1 exactly 2 matches. All the matches, no match. So exactly 2 matches, it means the first and second can be won, the third will be lost. First and third can be won, the second will be lost. Second and third can be won, and the first is lost. So you shall come and substitute win, win second, lose third. Win first, lose second, win third. Lose first, win second, win third. And when you use the calculator, you'll come up with 37 over 125. What about if all the matches are won? So win first, win second, win third, come up with 6 over 125. What about if no match is won? So lose first, lose second, lose third, to give you 24 over 125. That was part A. Part B, they said if a random variable x is defined as the number of matches won, part A, Roman 1, construct a probability distribution table for x, and Roman 2, calculate the expectation of x. So here we have x equal to 2, x equal to 3, x equal to 0. But x equal to 1, we don't have it yet. So we have to first calculate it. It will be the remaining probability. So x equal to 1 will be 1 minus all the probabilities to get 58 over 125. Then you can draw a probability distribution table. So this is a table having values of x and their corresponding probabilities. So when x is 0, probability is that. When x is 1, probability is that. When x is 2, probability is that. And when x is 3, probability is that. So that is what we call a probability distribution table. They also asked for the mean. So mean will be x px. So x times its corresponding probability. X times its corresponding probability. This times this. And this times this. So when I use the calculator, I'll come up with the mean they wanted. So part A required candidates to determine the probabilities with different given conditions. And part B required candidates to construct a probability distribution table for the random variable and hence obtain the expectation. It was a very popular question. So for weakness that candidates failed to choose the correct entries to use in order to determine the required probabilities under different conditions. So they failed to get the complements for win to be the losses. So W complement will be 1 minus probability of W, so they failed to do that. Others failed to identify the distribution as a discrete random variable. So they did not tabulate. So advice to teachers is that teachers should expose students to probability theory and discrete random variables, and also encourage students to apply all the laws of probability appropriately. So now we shall go to question 16, which says, two airstrips P and Q are 100 kilometers apart, P being west of Q. Two helicopters A and B flying simultaneously from P and Q respectively at 11 a.m. Helicopter A is flying with a constant speed of 400 kilometers per hour in the direction north 50 degrees east. Helicopter B is flying at a constant speed of 500 kilometers per hour in a direction north 70 degrees west. Find part A, the time when the helicopters are closest together, and part B, the closest distance between the helicopters. So first is to make a sketch, because we have to convert from magnitude to vector. So first of all, they told us that P being west of Q, that is why we are seeing here, P is this side and Q is this side. Then in vector form, it will be A relative position vector of A relative to B. Position vector of B relative to A. So that means that you stand at A and locate B. Remember, A was at P. If you look at the question, let's go back to the question. In the question, they said A and B fly simultaneously from P and Q, meaning A is for P and B is for Q. Therefore, here A will be here at P, B will be at Q. Now if I stand at A and I locate B, it will be entirely horizontal and to the right, meaning it will be positive. That is why there is 100, 0. Now why am I using RBA and not RAB? So when they don't specify the order, sometimes they will specify the relative position vector, but when they don't specify, like in this question, what you do, you look at the velocities. This one is for A is 400, for B is 500. So B is big, the velocity of B is bigger than the velocity of A, meaning the rotative position vector will be B followed by A. That is why you have RBA. So that was this position. Now what about velocity of A? Velocity of A is 400 kilometers per hour in the direction north, 50 degrees east. So we shall come here and make a sketch. So this is the north, 50 degrees east, but we need an angle to the horizontal, which is 40. Therefore I can resolve. And it will be 400 cos 40, 400 sin 40. The next will be the velocity of B, which is 500 in the direction north, 70 degrees west. So we shall come here and make a sketch. Then we can resolve. So I've converted from magnitude direction to vector. Therefore we can proceed and say, first of all, we shall get the relative velocity, which is Vm minus Vb, to give you these to 4 decimal places. Then we shall code the formula for shortest time taken. It is magnitude of r relative position dot relative velocity over magnitude of relative velocity squared. So relative position is that, relative velocity is that, it has to be dotted, then relative velocity magnitude is that. Now there is no square root because of this square. Square takes away the square root. Then here the dot must be seen. Then we shall, dotting means this times this gives that, plus this times this to give you that. Now this magnitude means what is negative becomes positive. So we shall come and make it positive, and here you shall get this hours, then in minutes it will be that. So they started at 11 a.m. Therefore we shall come and say that when I add 8 minutes to 11, I'll come up with 8 minutes past 11. And that's the answer they wanted. Then part B, they wanted the closest distance between the helicopters. So closest distance, first of all, relative position at any time t is given by that initial relative position plus t times relative velocity. So I'll come and substitute for t to give you this in vector form, but the one distance meaning it has to be magnitude. So this is the answer they wanted. So the question required candidates to find the time and distance of closest approach of 2 helicopters flying at different given velocities. Candidates failed to interpret directions from the given bearings. So those sketches we drew, some candidates couldn't draw them correctly. Then so resolving was a challenge in order to obtain the velocities and displacements. And finding the correct time of after 11 a.m. of closest approach was also a challenge. So when after getting t equal to 8 minutes, you have to come and state that the time is 11:08 a.m. Then also obtaining the magnitude of the closest distance was a challenge. Most students stopped at the velocity part, the displacement part. So advice to teachers is that teachers should demonstrate how to obtain the directions of velocities and displacements by resolving vertically and horizontally from the correct diagram. Diagram must be correct. They should also guide students to explore various methods of finding time for closest approach. So there is dot product, there is differentiation, there is geometrical approach, and there is gradient method. So in this video, we have looked at the method of dot product, but there are also other methods which you can look at. Then teachers should emphasize the finding of magnitude of closest distance. After getting displacement, we must get magnitude, and that magnitude is what will be the distance. So in summary, the well done questions in this paper were these ones, the poorly done were these, most attempted and least attempted. And the question will always come from three parts. The first part is mechanics, second part is probability, and the third part is numerical. So for mechanics, there will be 3 questions in section A, 3 in section B. Statistics and probability, there will be 3 in section A, 3 in section B. Numerical methods, there will be 2 in section A, 2 in section B. So that brings us to the end of this video. Thanks for watching, and bear in mind the next video will be on Uneb 2018, because 2019 is already available, so next will be 2018. So if you are not yet subscribed, please click on the subscribe button on this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.